In the physical world, gravity isn't just a force, it's an invisible architect of reality. It shapes galaxies, governs planetary orbits, and determines why your coffee cup falls when you drop it. But what if I told you there's an equally fundamental force governing every digital system in your organization? Welcome to the Entropy Dojo, a conceptual space where information entropy follows its predictable laws and acts upon all objects. As if it were a universal digital gravitational force pulling all data systems toward disorder. Shannon's mathematical gravity. Just as Einstein revealed that gravity isn't just a force but the curvature of space-time itself, Claude Shannon discovered that information entropy isn't just a measurement. It's a fundamental force that governs how uncertainty behaves in nearly any system. Consider Shannon's formula. H equals negative sum of pi times log base 2 of pi. This isn't merely a calculation. It can be considered as a gravitational constant of information space, as universal and predictable as F equals gmm over r squared in physics. Similar to gravity, Shannon entropy operates identically across all domains. Network performance, customer behavior, supply chains, financial markets. 1. Always pulls systems toward maximum disorder unless other forces intervene. 2. Cannot be ignored or turned off. Every information system experiences entropy's pull. 3. Follows predictable mathematical laws that let you forecast system behavior. 4. The unit of measure is a number that can be applied in many functional computations. The physics of your digital world. In the Entropy Dojo, your business systems don't just generate data, they exist in an informational gravitational field, where entropy acts as the dominant force, information mass. Complex systems with many possible states have greater informational mass and create stronger entropy fields. Your e-commerce platform pulls harder toward chaos than your simple contact form. Entropy wells. Highly organized systems create gravitational wells that pull surrounding chaotic information towards structure. Your well-designed databases stabilize nearby data flows. Orbital mechanics. Feedback loops create stable orbits around optimal entropy levels. Your monitoring systems maintain circular paths around acceptable uncertainty ranges. Escape velocity. Maintaining low entropy organization requires continuous energy input, just like launching rockets against Earth's gravity. Your DevOps teams provide the constant thrust needed to keep systems organized. Why this changes everything. Understanding Shannon entropy as gravity transforms system management from reactive firefighting into proactive force management. Predictable trajectories. Instead of wondering, will this system fail? You can calculate exactly where your entropy levels are heading. Based on current position, velocity, and acceleration, just like predicting where a thrown ball will land. Energy budgeting. You can begin to quantify how much organizational energy is required to maintain systems at specific entropy levels. Resources, monitoring, maintenance against the natural gravitational pull toward disorder. Gravitational assists. Like spacecraft using planetary gravity to gain speed, you can design systems that harness entropy's natural flow. Rather than fighting it, let chaos help you identify optimization opportunities. System architecture. Build information systems that work with entropy's gravitational field, creating stable orbits around optimal uncertainty levels, rather than constantly burning fuel to fight natural forces. The entropy engine model advantage. This is where the entropy engine model becomes your mission control center. By treating Shannon entropy as gravity, this engine doesn't just monitor your systems. It tracks their orbital mechanics mapped in a virtual 3D information space where we all abide by the same rules of physics. You can track a time series of Shannon entropy, measured in bits per sample, and then analyze the system's stability in real time by computing its first and second derivatives. The first derivative, or the rate of change of entropy, tells us if the system's uncertainty is increasing or decreasing. A positive rate of change suggests the system is becoming more random. The second derivative provides a measure of how quickly this change in uncertainty is occurring. X-plot position, where your system sits in the entropy gravitational field. Y-plot velocity, how fast you're being pulled toward or away from disorder. Z-plot acceleration, whether entropy's gravitational pull is strengthening or weakening. Just like NASA predicts satellite trajectories in advance, you can forecast your system's entropy path and make course corrections very quickly, as or before problems get worse. Real-world applications, network operations, your servers exist in entropy fields. Monitor gravitational pull toward chaos, apply thrust, patches, updates, load balancing, to maintain stable orbits around optimal performance. Customer experience. User behavior creates entropy wells, design touchpoints that work with natural information flow, rather than fighting customer chaos. Supply chain. Logistics networks follow entropy physics, predict disruption cascades by tracking how disorder propagates through your gravitational field. Financial risk. Portfolio entropy behaves like planetary motion. Use gravitational models to optimize asset allocation. And predict market instability. The navigation advantage. Teams that understand entropy as gravity gain a fundamental advantage. They stop fighting natural forces and start navigating them strategically. Instead of constant crisis management, you develop orbital mechanics expertise. Calculate optimal entropy trajectories, design gravitational assists for system improvements. Budget energy efficiently against entropy's pull, predict when course corrections will be most effective. Your Entropy Dojo training, ready to master the physics of information entropy in your organization. Pick one critical system and begin tracking its entropy position, velocity, and acceleration. Watch how it behaves like an object in a gravitational field. Build intuition. Notice how entropy pulls your systems toward disorder, and identify what organizational forces you're using to maintain stability. Scale understanding. Once you see entropy physics in one system, you'll recognize the same patterns everywhere in your digital universe. Where the challenges lie. The difficulty isn't in computing entropy, it's in making it useful. Defining state spaces. You must decide what constitutes the system's states for entropy measurement. Interpretability. Teams will ask, if H rises by 0.3 bits, what does that mean for me? Clear mappings from entropy changes to operational actions are needed. Noise versus signal. Entropy is sensitive to normal variation. Filtering out false positives so engineers don't chase phantom chaos requires careful baselining. Scaling and automation. Large-scale, high-frequency entropy calculations across multiple systems need distributed compute. Spark, Flink cloud pipelines, not impossible, but resource-intensive. Human adoption. Engineers are used to CPU percent error rates or queue sizes, not bits of entropy. Cultural coaching will be required. The fundamental truth. Shannon entropy isn't just a mathematical tool, it can be the analog to gravity of information space. Every digital system in your organization exists in this gravitational field, following predictable laws of entropy physics. The question isn't whether your systems experience entropy's gravitational pull, they all do, constantly and universally. The question is, are you navigating these forces strategically, or just falling wherever entropy's gravity takes you? Thinking of Shannon entropy as gravity doesn't just improve your monitoring. It transforms you from a passive observer into an active and independent navigator of the information universe your business operates within. Time to enter the Entropy Dojo. Begin to master the 3D physics of digital uncertainty by continually managing the plot of information entropy in its universe of entropy physics. As a moving spot on your system's chaos radar. Yes, it can actually work. The idea is familiar, math is packaged in libraries, the tools exist, and the plumbing is off the shelf. The real challenge isn't technology. It's in modeling, interpretation, and adoption. AI's love for crunching datasets can help perform 3D information entropy pattern, matching on models of different system states. So, the entropy engine is feasible and buildable. But whether it delivers transformative value will depend on how well entropy metrics are translated into actionable insights that engineers and leaders can actually use. What entropy gravitational effects have you noticed in your systems? Share your observations in the comments.